Hello, honor students. This is a video to help you to understand how to do quantum numbers. Quantum numbers are the addresses of the electrons, and in order to figure out the address of every electron, we first have to do an electron configuration. So we're going to start off by going down here to this periodic table, which you won't see in your notes, but you can look at a periodic table in your textbook or the one that we gave out in class. And we're going to figure out the electron configuration of a couple of elements. So there's the helium. Move it from over there. We're going to do the electron configuration of chromium. How about that one? All right, so we start off with, excuse me about that, 1s2, 2s2, 2p6, 3, remember these are the principal energy levels over here, the ends. So 3s2, go straight across to 3, 3p6, and then 4s2, and this goes down, so that's a 3 and a 4, so that's 3d4. That's the long one, and that's for chromium, and we'll do the abbreviated form. We'll go up one level into the end, so we'll have argon. So instead we'll say argon, and we'll just put the new stuff. 4s2, 3d4, which is this stuff right here. And all of these guys are inside of argon. So this is the abbreviated electron configuration. Now let's do the abbreviated orbital notation. The 4s2 would be up, down, and the 3d4 would be 5 lines, 1, 2, 3, 4, 5, but 4 electrons, up, 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 and up. So in order to do quantum numbers, we have to start off with writing the electron configuration, the EC, and the ON, the orbital notation over here. All right, so this one, normally you would put the 4s2 right above that and the 3d4 right above that, so I know what you have. And then what I'm going to ask you is to give me the quantum number for the last electron that you write down, which will be this one. And I'm going to ask you to circle that electron that you're going to give the quantum number for. So we're going to give the quantum number for this one. So I'm going to go ahead and write this information in the above example, 4s2 and 3d4. So 4s2 and 3d4, and the orbital notation, 1, 2, 3, 4, 5, up, 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 up. Okay, and we're going to figure out the quantum number for this electron. All right, the first quantum number is the principal energy level, and that's these numbers here. Those are the principal energy levels, the numbers in the front, because we get those from these numbers right here, the principal energy levels. So those are the ends. That's where this comes from. So its first quantum number would be a 3. The second one is the azimuthal, and the way you figure that out, it's going to be the L, which it's depicted as, is equal to n minus 1. So it actually goes from 0 to n minus 1. So in this case, n is a 3, so it would be from 0 to 2, because 3 minus 1 is 2. Now, I don't have to memorize that. That's the formula that a lot of the scientists will use. I don't memorize it. I just put them in order, S, P, D, F. Start with 0 for S, P is a 1, 2 is a D is a 2, and 3 for F. So S, P, D, F, 0, 1, 2, 3. So this is in a D sublevel, and D is a 2. So the second quantum number is a 2. So to me, it's easier to write SPDF 0, 1, 2, 3. But this is where they get it from. N is equal to 0, 2, anywhere between 0 and n minus 1. I mean, L is equal to anywhere between 0 and n minus 1. If n is 3, that would be anywhere between 0 and 2. In this case, it was 2. The next one is the magnetic quantum number. Sometimes it's written with an M little sub l at the bottom. And the way it is, it goes from plus L to minus L. So it has that range from a positive L to a negative L. So if L was a 2, it would go from a positive 2 to a negative 2. Or actually, I need to write it in the opposite direction because you want to think of the number line. So let's write it in the opposite direction. It would go from a negative L to a positive L. And so on the number line, think about that. Somewhere in here, you'd have a 0. Well, that's the way you do it scientifically. The way I do it is I just write down S. And since it only has one position, that's the 0 position. P has 3 lines, 3 shapes, and so the 0 goes in the middle, and then a negative on one side and positive on the other, just like the number line. Negative to the left, positive to the right. D has 5 shapes. So the right in the middle is the 0, and then you count up like a number line. Negative 1, negative 2, negative 2, negative 1, 0, 1, 2. Okay, that's the 5 spots. 3, 4, 5. What about F? F has 7 shapes, so it would be a 0, and then in 1, 2, 3, 4, 5, 6, 7. 7 positions, just like that. So that would be -3, -2, -1, 0. +1, +2, +3. Okay, so what about ours? Ours is in the D position. Okay, so D, and then I have to figure out which one is it? Which one is it in? Well, let's look. Here's the D position. This is the 0 spot. That's the -1. That's the -2. That's the -1, 0, +1, +2. See, I just took this and put it right underneath the 5 spots. So it's in the +1 spot. So the next quantum number is +1. And it only had that electron is the only one in here that has the +1. And the last one is the spin, and spin is the easiest quantum number. If the electron is spinning up, you give it a +1/2. Don't ask me why, I just know that's what's true. If it's spinning down, you give me a -1/2. So this electron is spinning up, so its last quantum number is a +1/2. So what are the 4 quantum numbers for this electron? It's 3, 2, +1, and +1/2. Okay, that's the 4 quantum numbers for this electron. All right, now let's do a couple of examples. And I'll erase this up here so I can kind of write on it all. Okay, so let's do a couple down here. Write the electron configuration and orbital notation for nitrogen and give the quantum numbers for the last electron added. So nitrogen, I'm going to go up here and look. Let's find nitrogen on my chart. And here's nitrogen, element number 7. The electron configuration, okay, it's going to be 1s2, 2s2, and this is still energy level 2, 2p3. So that's electron configuration. 1s2, 2s2, 2p3. Now what's the orbital notation? 1 shape for s, 3 shapes for p's. Up, down, and the p's have 3, 1, 2, all spin up. And then it says to give me the quantum number for the last electron added. Okay, so let's the first quantum number is the principal energy level. That's the N, that's the 2. So the first quantum number is a 2. The second quantum number has to do with what kind of suborbital is it? It's a p. Remember, S is 0, p, d, f, 1, 2, and a 3. So this is a p sublevel, so its second quantum number is a 1. The third quantum number has to deal with, okay, it's a p orbital. Now, which one of the p orbitals? Well, there are 3 possibilities. The middle one is always a 0. This one is the -1, and this one is a +1. This one is in, so that's a 0, a -1, and a +1. It's in the +1 position. And the last quantum number is the spin. It's spinning up, so it's a +1/2. Those are the 4 quantum numbers for the last electron in nitrogen. Okay, write the electron configuration and orbital notation for zinc and give the quantum numbers for the last electron there. Okay, let's go find zinc. Here's zinc. All right, let's write the electron configuration. It's 1s2, 2s2, and 2p6. So I'm going to write all those down. 1s2, 2s2, 2p6. What else for zinc? 3s2, 3p6, 3s2, 3p6, and what else for zinc? 4s2, 4s2, and then remember right here it has to go down on energy level, so now it's at 3d, 3d10, 3d10, and that's where we end. That's where zinc is, at 3d10. Okay, now orbital notation for zinc. Write my lines. Okay, one shape for S's, 3 for P's. One shape for S's, 3 for P's. One shape for S's, and 5 for D. 1, 2, 3, 4, 5. Remember, S, P, D, F. Shapes 1, 3, 5, 7. All right, there are 2 electrons in this one, 2 in this one, 6 in this one, 2 in this one, 6 in this one, 2 in this one, and 10 in this last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's circle the last one that we wrote, and let's give its its quantum numbers. The first quantum number is the energy level, the N. So the first quantum number is a 3. The second quantum number tells you what sublevel, the D. Okay, now for sublevels, we go S, P, D, F, 0, 1, 2, and 3. So the sublevel is a 2. I don't know why they don't just start with 1 for the S, but they don't. The third one is, okay, it's in the D, but which one of the D's? The middle one is always a 0, then it's a -2, a -1, +1, and a +2. So that electron's in the +2 position. This +2 sublevel. And is it spinning up or down? It's spinning down, so it would be a -1/2. There's the 4 quantum numbers for this one electron. It's the only address for that electron. Then the electron right next to it would be exactly the same. So let's say this electron right here would have exactly the same address. It would be 3 energy level. It would be a 2 because it's in the D sublevel. It would be a +2 because it's in the +2 position of the D's, but it's spinning up. So it would be a +1/2. Notice the addresses are almost identical except for that last position. So no 2 electrons have the exact same address. I hope that helps.